Review for lesson 3. When I looked over this lesson and before I began to write it, it brought back memories over the past years. I thought about when I was going through classes and the instructor strongly emphasized one thing when he talked about conductors. The biggest and most dangerous conductor there is out there is you. A conductor is anything that allows current to flow through it. The body is made up of water and a lot of soft tissue with little resistance, so it makes a great conductor for electrons to flow. Conductors come in all shapes, sizes, and materials. Some of the most well-known conductors we use are aluminum, lightweight brass, switch parts, and copper. Copper, figure 3-2, is a great conductor and the most widely used conductor in electronics. Remember, electrical conduction is merely the transferring of electrons from atom to atom. Conductors allow you to force electrons in one end and out the other at the speed of light, 186,000 miles per second. The unit of measurement for conductors is the Siemens, and the formula used to find conductance is G equals 1 divided R. Conductor size is determined by the cross-sectional area. The cross-sectional area will tell you how much current the conductor will allow to pass through safely. In this field, when referring to conductors, we are speaking about a wire and its size. We use a wire gauge to actually read the size of a wire, figure 3-3. A system called the American Wire Gauge System, figure 3-4, was created to make it easier to determine the size of electrical wire and its current carrying capacity. The larger gauge number equals the smaller current carrying capacity. The cross-sectional area. The wire gauge systems has changed and the demands from the electronics field has grown. The first system made a change from 1 being the largest size of wire to that what we call oct, which is 0 and 00 and 000 and quadruple 0, or 1-4 oct, or 1-4 oct, 1 through 4 oct. As demand increased, the circular mills area was added as well. The circular mill system is based on the diameter of the conductor being measured in mils, 1/1000th of an inch. Any wire larger than 4 oct are 250 kcm or kilo circular mill. Remember, 1 kilo is 1,000 to 2,000 kcms or 2,000 kilo circular mills. If you have a 35 kcm to 300, it is equal to 35,000 circular mills. The number of circular mills, or C mills, in a conductor is equal to the diameter of a round conductor squared. Simply put, a wire with a diameter of 6 mils has an area of 36 C mills. The wire that was just covered has an ability to pass current through it that makes it unsafe for people to touch. For this reason, it must be covered up in an insulated film with some type of material. This material, which is not conductive or does not allow electrical current to pass through it, is called an insulator. Some of the different types of insulators are rubber, plastic, wood, and synthetic material. Rubber tape, such as the figure shown in 3.5, will be used as your personal insulator when performing field work. As time goes on, you will know what the different colors represent, but black is for general use. The type of insulation will be determined by the electrical application. For example, if you are installing Christmas lights in your yard and need an extension cord, the wires inside the cord should be insulated with some type of weather-resistant insulator. Some insulators we use are marked with special coating to indicate their use. R is rubber, H is heat, M is oil resistant, and C is corrosion, which are the ones you would see on a regular basis. Although conductors come in many shapes and sizes, you will encounter two types of conductors: wires stranded, figure 3.6, many wires twisted together to make up the conductor, and solid, figure 3.7, which is one wire. Resistance is low in conductors, but must be considered when running long distance wire pulls. There are four factors that will affect the resistance. 1. Cross-sectional area of the conductor. The larger the diameter, the lower the resistance. 2. Type of material resistance. Values vary with type of material. 3. The length of the conductor. The longer the conductor, the greater the resistance. And the temperature of material. Resistance is proportional with ambient temperature. See figure 3-8. Ambient temperature is the temperature of the material surrounding the conductor, such as water, air, or soil. In cases where the temperature is so low it causes the conductor resistance to approach zero, the conductor turns into a superconductor. Figure 3.9 shows a process for creating a superconductor by reducing the temperature of the conductor. They can be found in medical imaging equipment, but operate on the principle of a motor. Because all of the variations in our field and the need for continued safety awareness, there are organizations that exist to ensure safety guidelines are followed. The National Fire Protection Agency provides us with information on fire prevention, electricity causes C-class fires, and can be put out by disabling power and by treating the fire as a Class A fire, any fire that leaves an ash. The National Electric Code, or NEC, set the standard on how electrical and electronic equipment should be installed to ensure safety for both people and property. The NEC is a 700-page document that will become one of your best friends. The Underwriters Laboratories, Inc., a nonprofit organization that conducts tests on products to ensure public safety. They created a seal to attach to a product that tells the customer it meets safety design standards. The Occupational Safety and Health Administration, or OSHA, part of the Department of Labor, considered the big cheese in the industry responsible for your safety on the job. They have the power to shut down work sites and enforce fines. Although not all facilities are governed by OSHA or municipalities, they still follow their standards. The National Electrical Code set a maximum voltage drop across each branch. A branch circuit, figure 3.10, is wiring from the panel to the last device on that circuit. A maximum of 3% voltage drop is allowed, and a formula can be found on page 59 of your text. This formula can be very helpful when trying to figure out a conductor size that will not cause a high voltage drop. There are three conductor pathways to provide a good conductive path for current flow. The breadboard, experimental board, consists of lots of holes lined to an insulated material. You will insert resistors, switches, and various electronic devices via jumper wire to create circuits. See figure 3-11. The printed circuit board is the most common or most commonly used and is made up of conductor material with thin strips of circuit paths, for component connections. It uses a heat strip. It uses a heat strip for common connection points and reduction of heat. Solder is used to make all connections permanent at the connection pads. Figure 3.12 bottom view. Although you will learn how to troubleshoot these boards down to faulty components, once in the field you will look at cost first. Most times you will just replace the whole board. See figure 3.13 top view. The chassis is the metallic surface where the components are mounted, and it serves as a path of the circuit. It serves as part of the circuit. Chassis pathways are not in great use, but in your text on page 61 you will find a brief description of the metal chassis pathway. Please spend just a brief moment reviewing it, because you are unlikely to encounter it again. In building and troubleshooting circuits, there are some devices that are used in most electronic circuitry. Switches, figure 3.13, are used in circuits to stop and start the current flow in a circuit by the use of a mechanical actuator. This actuator comes in a variety of forms, including slide, toggle, and push button. The name will indicate the type of actuator. The letters SPST stand for single pole, single throw, which means that the switch only has one path for current flow and will only operate one circuit. A SPDT, single pole, double throw, has one common connection point and can control current to two different circuits, but only one at a time. If you see DPDT, it means two circuit paths for current flow with two common connection points. It's like having two SPTP placed in parallel. Switches are rated by the amount of current they can withstand. If a switch is only rated for 3 amps, exceeding it will prevent it from opening. And at the same applies for voltage. You cannot exceed the rated voltage of a switch. Connectors come in many types and are used to connect wires, electrical conductors together. There are many types of connectors available for a variety of usage. The types that will be used by you more often than any other are the wire nut, figure 3.14, and crimp type, figure 3.15. Wire nuts are easily used by putting the wires together and twisting the wire nut over them. The crimp type requires a tool. For this type, you put the wire in the connector hole and crimp with the tool. Once the circuit is built, we must protect the equipment and or components because of shorts, grounds, and opens. The protection devices you will need to familiarize yourself are the fuses and circuit breakers. There are others out there, but these two are in every electrical circuit around. Fuses 3.16 provide short circuit protection and are rated by voltage and current capacity. If a fuse is rated for 6 amps and it exceeds 6 amps, the fuse will open or blow to prevent damage to other electronic or electrical components. Circuit breakers, figure 3.17, are used to protect a circuit from overloads and shorts and are resettable components. The circuit breaker doesn't have to be replaced when it trips. It is telling you that there is a problem. The circuit breaker can be reset. Like fuses, circuit breakers are rated by voltage and by current and operate similarly. There are two ways the circuit breaker can trip, and they are designed by the way they trip. One uses bimetallic strips and the other uses magnetism through coil current or magnetic. The magnetic breaker is more accurate and costs more, but it is more widely used in the industry. In some homes built prior to the mid 1980s, fuses were used to protect the circuit, but all homes built today use circuit breakers. That protection includes a lightning circuit, which brings me to the next topic, lightning. Lightning can be produced in many different ways, but for the purposes of this course, we will focus on the lighting that is produced via electricity. Lighting can be produced in many different ways, but for the purpose of this course, we'll focus on lighting that is produced via electricity. This is accomplished by sending current flow through a filament or energizing through a gas. There are two types of lights, incandescent and fluorescent. Incandescent was discovered by Thomas Edison in the late 1800s. It uses current flow through the filament to produce light. It is the type of light with the threaded metal base that is screwed into a socket. Fluorescent lights use energized gases such as mercury vapor to produce light and will produce 20 times more light than incandescent lights. Fluorescent lights use a ballast to control the current, produce a higher voltage for the filament, and are pin-based or screw-based. When we buy lamps or lights, we generally select them according to the voltage requirements and the watts, which determine the brightness. The amount of light produced is based on candela, which is the amount of light generated by one candle. A lumen is the amount of light generated by a system of lights, and lumens per watt is the amount of light produced for each watt of energy. The last circuit device we're going to cover in this lesson is the resistor. It is one of the most common components used in electronics and is used to create variable voltage drops and limit current. Resistors come in all shapes and sizes and are rated according to their ohmic value. The wattage rating on a resistor tells you how much heat the resistor can withstand before it opens. There are many types of resistors, but I'm going to cover just a few, and you will see daily. The first is a film resistor. It is a small and resistor and will be found on electronic circuit cards. The resistor is the adjustable resistor. It has the two normal ends you use to connect to a circuit, but it also has an adjustable sliding tab. The tab can be moved up and down, which will cause the resistance to vary. The most common type of adjustable resistor is a potentiometer, which has a rotary knob to adjust the resistance. This resistor can be found in house lighting to control the lights. In that case, we call it a dimmer switch. The last resistor is a thermistor, and it is used to dissipate large amounts of heat in electronic equipment or circuits, which will cause high current. Resistor color coding is used to determine the ohmic value of the resistor. Each band has its distinct representation. They usually have 3 to 5 bands at most. The first band is the first digit, second band the second digit, third band is the multiplier, fourth band is the tolerance, and if there's a fifth band is the failure rate. The best way to remember how the colors fall into place is to come up with some type of acronym, words used to represent each letter. This is mine. Bad boys race our young girls behind victory garden walls. Get started now. I've used it ever since I've left basic electronics school.